Today we will explain how the vibration analysis will be done for bearings in the motor. We will take here example motor of bag house fan in cement plant. We will check, and this is points for past time with failure in the bearings. As we see here, the first step to analysis of the vibration for any points in bearings of motor, and bearings of fan, and any equipment, bearings of gearbox or any equipment. The first step here, we will open the spectrum and we will try to adjust as from previous the 1x. And when we set the 1x, we can check on the harmonics of this is the 1x. Where here in SKF aptitude, we can press about the harmonics from this harmonic cursor, and we see here 1x, the amplitude 0.55, 0.1, and see we can use this is the plus mark to large it and the zoom out to decrease it to see everything. And as we see here, the harmonics not very much, but we see some peaks in other frequencies. How can we check what this is frequencies? Can we check from them? From this the bearing, from the bearing we will overlays the bearing frequencies to see what this is. We'll try to open it again. We open here the horizontal and we will return to the past date to see what happened for this. For the old bearing, we will specify the 1x. This is the first step, and then we will check the harmonics and we will see about it, and then we will overlay the frequencies of the bearings and see what will match with these peaks. We cannot see very much much between the bearing in this point, but we can check about the time wave frequency, the time wave, and see where we see also see the overall the reading of the vibration this point 1.1, and we will try to go to the other points before we take decision about this, and check also about this is the acceleration and see his spectrum where we is it, and see here the time wave and check the other points. All these steps before we take any decision. We see the properties, what the features of the spectrum, what is the features of the time wave, and see, oh, we see here more impacts in the time wave. Therefore we can to concentrate about them. We will see here in the vertical point how is the frequency bearings. Oh, we see the problem here. See here, if you see the harmonic, the eighth harmonic of the outer rest of the motor bearing, it is very high. It is reached to 0.6 and the overall 2.9. And we can see here from the beginning, see, it is very low amplitude for these frequencies, but these frequencies there are, and can also check from here. Oh, here, and where is the amplitude as the reciprocal of the time. We can see the harmonic, the frequency, to see how, when well this is the impacts repeated with every one resolution, one rotation of the gear of the motor, and we can add this to check the other this. As we see here, how much the one frequency, 3413 CBM. And here, if we see with between the two impacts in the time wave, we see the frequency near this. Therefore, this is clearly problem in the bearing, in the outer race. The vibration analysis, not in this is easy way. This is the search journal about the problem or the floats in the bearings. Therefore, we see the set 1x frequency, check the harmonics, check the frequencies of the bearing, see if there are high frequency related to the bar in the motor. We check about all the frequencies, the force frequencies that related to the component and the equipment. But see here, it is matched with the bearing directly. Therefore, we will check in the past readings and see how it is how much it is still. See, this is on November 2019. Also in the previous, in the October, how was it? Also in September, how was it also? When was it? This is, we will check by the theta cursor that determine as how much the time between impacts in the time wave, and see here nearly the bearing frequency. Therefore, as we see in the near, we will change the bearings. We see here the impacts, also appear impacts in the rotation, the speed of the motor. And we will see here after replace the bearings, how is the amplitude of the acceleration and the time wave. Also, can we compare here? See how much is the difference. See, this is the triangle with the orange color. This is the active 12 April 2020, and this is 11th February 2020. How much? This is the black. Therefore, if we compare between them, we see the clearly difference between the fault and the bearing. Now we check for 1 point only. Can we check about the GE, the envelope acceleration, that we see it here as was before with the fault bearing? It was high. When we change, it is decreased. And see here, oh, it is big problem as we see here. Oh, it is the outer rest problem clearly. and if we can make the compare between them. Also, if we check the acceleration, what about it? CB4 1.8 G with the acceleration the filter with 2 kilohertz, that equal 120 thousandths CBM, where we can see here all this is the impact, and we will see it this in the new, how we can compare it. See how we can. Therefore, to execute all these steps for all the points in the plant and all equipment, where we have for every bearing 6 points, 4 in the horizontal and 1 in the vertical and the other in the axial. All these points, to analyze them need some time, must be, and check what this. Sometimes we cannot see in other points in other axes, therefore we must be see in all axes. As we see here in the axial, there are no anything. Also here in the vertical of the drive motor bearing, as we see, there are much. But if you see here in the drive and motor bearing, we see the problem clearly, where this the bearing more damaged. All these points must be inspection when we do vibration analysis. Therefore, if we can add the AI for the vibration analysis, we will reduce the time that the vibration analyst need to perform his job, and this is will improve his job directly, where he will not waste his time and check for inspection for all this. Also here in this this is the software we can active this the overall alarm, but it is not enough because there are problem. Where is the problem? Where is this? As we can see here, the danger level with 7, and this is 4. This according to the ISO, but here the problem with very less vibration. Therefore, we want AI tool to help the vibration analyst to decrease his time.